how the brain processes language and communication. Today we dive into the fascinating world of how our brains decode and produce language, enabling us to connect with others through words and speech.
And today we'll explore the incredible processes our brains undergo to understand and produce language. From hearing and interpreting words to constructing meaningful sentences, our brains are hard at work behind the scenes. Broca's area helps us form coherent sentences and express our thoughts verbally. When this area is damaged, people may struggle with speech production, a condition known as Broca's aphasia. Next is Wernicke's area, located in the temporal lobe. This region is essential for understanding spoken and written language. Damage to Wernicke's area can result in Wernicke's aphasia, where individuals can produce fluent speech, but it often lacks meaning and coherence.
The auditory cortex, located in the temporal lobe, plays a vital role in processing sounds, including speech. This part of the brain is essential for interpreting the complex auditory information we encounter daily. When we hear someone speaking, the auditory cortex analyzes the sound waves and converts them into neural signals. These signals are then meticulously processed to extract various elements such as pitch, volume, and rhythm. Host. These signals are then sent to Wernicke's area for interpretation. Wernicke's area is specifically responsible for understanding the linguistic content of the speech. This process allows us to understand the meaning behind the words we hear, making communication possible. Without this intricate system, our ability to comprehend spoken language would be severely impaired, highlighting the importance of the auditory cortex and Wernicke's area in our daily interactions. Reading and writing involve a complex network of brain regions working together, creating a symphony of cognitive processes that enable us to understand and produce written language. The visual cortex processes the written symbols, transforming them into recognizable patterns. Meanwhile, other areas, including the angular gyrus and supramarginal gyrus, play crucial roles in decoding these patterns and comprehending the text, allowing us to derive meaning from what we read. Host writing, on the other hand, engages the motor cortex for hand movements, ensuring precise control over our writing instruments. Additionally, Broca's area is activated for language production, helping us formulate coherent sentences and express our thoughts clearly. This intricate coordination between different brain regions allows us to translate our thoughts into written words, bridging the gap between abstract ideas and tangible text. The seamless integration of these processes is what makes reading and writing such remarkable human abilities. Language development in children is a remarkable and intricate process that begins even before birth. From the early stages of babbling as infants to the more advanced stages of forming complex sentences as they grow older, children's brains are rapidly developing the neural networks needed for language acquisition. This journey is filled with milestones that reflect their growing understanding and use of language. Host, parents, and caregivers play a crucial role in this development by providing a rich linguistic environment. They engage in meaningful conversations, read to their children regularly, and introduce new vocabulary. These interactions not only enhance language skills, but also strengthen the bond between the child and the caregiver, fostering a love for learning and communication.